Hello everyone. We'll continue with the chapter PNC. In the last class, we talked about how can we form different combinations, how can we form different possibilities of forming a word, forming a letter, right? So when we're talking about permutation, it has to be positioning, selecting as well as arrangement. Whenever there is a selection plus arrangement, both we talk about permutation. So when we write the let symbol NPR, this means that out of n things, we are choosing R, we are selecting R, and after selecting the R things, you are also arranging those R things. That is NPR. The formula was factorial n by factorial n minus R, where R can be any whole number till n. In that, we talked about NPN. NPN is factorial n. So NPN means the only thing that we need to do here is selection, is arrangement. There is no selection involved. If out of n I'm taking n thing, then there is no selection. The only thing that I am doing is arrangement, right? So if I have, for example, letters R, O, S, E, right? Then there are four letters. In how many ways can I form a two-letter word? So I have four options. From that, I need to select two, and then I also need to arrange because it's a word. So obviously the arrangement matters. So in that case, I'll be writing 4P2. In this selection and arrangement, both are included, right? Now, when I'm going to form a four-letter word, if I say just form a word, I did not say how many letters or something. That means I'm talking about using all the letters. So how many letters were provided to you? Four. So how many words, how many will we use? Will we use four? So I need to form a four-letter word from the given four letters. So here, since it's word, yes, it is permutation. But there is no selection. The only thing we need to do is arrangement. Four letters needs to be arranged. So in that case, we can directly write factorial 4 because there is only arrangement involved. Now, if I want to say, for example, Sunam, if I want to start my word with a vowel, if I want to start my word with a vowel, so the first position has to be filled by a vowel. So either O will sit or E will sit. There are two positions, there are two options for this, right? Now, the remaining three places, does they have any restriction? No. The three places can be only arranged. We don't need to select. So the remaining three places can be arranged in how many ways? Wrong. Factorial three ways. Not three, factorial three. Because arrangement is involved, right? So answer would be 2 into factorial 3, 12 ways. Clear? Now, I asked you to do a couple of sums. 13 number. We discussed till 12, right? So, how many words of the from the word equation? So, in equation, there are 8 letters. Out of those 8, there are 5 vowels and 3 consonants. The first one is no restriction. That means there is nothing more added. The only question is how many words can be formed. So, how many words can be formed by using 8 letters? 8 factorial directly because the word thing is only to arrange, there is no selection. Then start. No, we need to calculate. We have to do the entire calculation. We can't stop at factorial. Start with the vowel, end with the consonant. So there are 8 positions. First position has to be filled by a vowel. So there are 5 options. The last place has to be filled by a consonant. So there are 3 options. Now, two letters, one of the letters sits in the first place, one letter sits in the last place. There are 6 remaining. Those 6 can be arranged in factorial 6 ways. So 15 into factorial 6. Yes. Now, all the vowels are together. So whoever, all the vowels means all the 5 vowels have to be together. So whichever letters we want together, what do? We treat them as a bundle. So all the 5 letters will be now treated as a bundle. So we have 3 consonants and we have this bundle. We have 3 consonants and we have this bundle. So there are a total of 4. So now 4 people can be arranged in how many ways? 4 factorial. Yes, now the vowels needs to be together, but they did not fix the arrangement. They can be presented in any which way. So the five letters, the five vowels can be arranged in how many ways? Five factorial ways. Clear?
Yes, ma'am.
Now, no vowels are together. No vowels are together. Okay. See, if the question would have been all vowels are not together. In that case, I don't want all five to be together. I'm okay with four, I'm okay with three, I'm okay with two, I'm okay with all different. I'm not okay with only one case, which is when they all are together. In that case, I would have done total minus together, total minus vowels together. So total factorial 8 minus vowels together factorial 4 factorial 5. But that is not what I asked. I asked no vowels are together. That means not even two vowels could be together. So if I want to do that, for example, vowel, 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 no matter how I write the three consonant, two of the vowels will definitely be together. It's impossible for me to write the vowels in such a way, the letters in such a way that none of the vowels come out together. That's impossible, right? Because there's a shortage of the consonants. So is it possible? No. How many answers? Zero. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
14. How many numbers can be made using the digits 1, 2, 3, 4, 5, 6, 7? How many numbers? 7 digits, so 7 digit number. So that makes it 7 factorial. Yes.
Yes, ma'am.
Yes, ma'am.
Now I want an even number. So for my number to be even, the last digit has to be filled by an even number 2, 4 or 6. So the last place can be filled in three ways. Now there are remaining six places. Those six places can be filled in any which way, and there is no zero also involved. There is no restriction. So the six places can be filled in how many ways? 6
6
factorial.
factorial.
So 3 into 6 factorial. Clear? Next, this one is even. If I want to know about odd. So for the number to be odd, the last place has to be filled by 1, 3, 5, or 7. So the last place can be filled in four ways. Yes. So one of the letters sits there. The six digits are still left. So the remaining six digits has to be clear.
Yes, ma'am.
Now, C divisible by 4. For that number to be divisible by 4, the last two digits has to be a multiple of 4. So the last two places has to be a multiple of 4. So क्या होगा? It can be 12, 16, 24, 32, 36. We don't have 44. Two fours we don't have, so that's not possible. 52, 56, 64, 72, 76. So the last two places has to be filled by one of these 10 options. Yes, either 1 to 12 has to be there, 1, 6, 16 has to be there, 2, 4, 24 has to be there. So the last two places has to be filled by one of the 10 options. So the last two places can be filled in 10 ways. Yes. So remaining five places, those five places can be filled in 5 factorial. So answer is 10 into 5 factorial 1200. Is there any doubt?
No, ma'am.
Everybody clear?
Yes, ma'am.
Yes, ma'am.
15. 4 boys and 4 girls are to be seated in a row. Find the number of ways they can be seated. So total 4 boys and 4 girls. So 8. So 8 people can sit in how many ways? 8 factorial. Yes. Now B, no two girls sit together. My first question, is B and D same? No, because in B it says that the girls should not be together, but in D it says neither the boys nor the girls should be. So that's a different answer. So for 2, the girls should not be together. So we first arrange the boys 4. So 4 factorial, the boys can be arranged in factorial 4 ways. Now there are these 5 gaps. In any of these 4 places, if I make the girls sit, they won't be together. The boys may be together, that's okay. But the girls won't be together, right? So what we need to do is from these 5 locations, I need to select 4 for the girls and make them arrange also. So my job is both selection and arrangement. So how many ways will be there? 5 P4. So 4 boys can be arranged in factorial 4 ways. There are 5 gaps in between them. Out of those 5, we need to select 4 places for the girls and then arrange them. Number of ways to do that is 4, 5 P4 ways. So total answer, required number of ways, factorial 4 into 3. Is it okay?
Yes, ma'am.
Yes, ma'am.
Not all girls are together. Not all girls are together. That means all the girls should not be together. So how do we do it? Total minus together. So total factorial 8 minus all the girls together because I'm not okay with that case. So all the girls form a bundle. So 4 boys in this bundle, 5 people. So 5 factorial. Now the bundle has 4 girls. So that will be 4 factorial. Boys and girls alternate. Boys and girls alternate. So first make the boys set. 4 factorial. Case 1, the girls can sit in these 4 positions. So 4 positions, 4 girls, no selection, only arrangement. 4 factorial. Or the boys sit 4 factorial. The girls can sit in these 4 positions. Right? Again, 4 positions and 4 girls, only arrangement left. So 4 factorial. So 2 times 4 factorial, 4 factorial. Clear?
Yes, ma'am.
All of you understood?
Yes, ma'am.
Yes, ma'am.
Question number 16. There are 4 married couples. Find the total number of ways in which they can be seated so that each couple is together. So basically, the placement will be done for a couple. So one husband wife a bundle, another husband wife bundle, another husband wife bundle. So one couple, 2, 3, 4. So 4 couple, 4 bundle. 4 bundle can be arranged in factorial 4 ways. Now, this particular bundle, the husband and wife can change among themselves in how many ways? Again, this husband and wife can arrange among themselves. Another bundle, they can also arrange among themselves. Now, this bundle can also arrange among themselves. Understood?
Yes.
Yes,
Understood?
Yes, ma'am.
Everybody clear?
Yes, ma'am.
yes, ma'am.
All of you clear? Any doubt till here?
No, ma'am.
Let's start ML Agarwal exercise 7.3. Okay, question number 1. P4, 3, that is 4P3. Factorial 4, 4 minus 3, 1. So answer 24. Number 2, P65, P65, 2. So 65, P2, factorial 65 upon factorial 65 minus 2, 63. Answer 65 into 64, which is 4160. Third, 7p5 factorial 7, 7 minus 5, 2 factorial 7, 6, 5, 4, 3, 2520. And number 4, 10p3 factorial 10, 10 minus 3, 7 factorial 10, 9, 8, 720. Any doubt? Hmm.
No, ma'am.
Whenever you open a factorial, you start with the larger factorial, keep on subtracting 1 till you get the smaller one. So 65, 65 minus 1, 64, 64 minus 1, 63. Prove that. So LHS and RHS. 10p3 factorial 10, 10 minus 3, 7 factorial, 10 into 9 into 8, so 720. RHS 9p3 plus 3 times 9p2 factorial 9, 9 minus 3, 6 factorial, factorial 9, 9 minus 2, 7 factorial. 9, 8, 7, 6 factorial gets cancelled. 9, 8, 7 factorial gets cancelled. 504, that is 720. That is same as LHS as RHS. LHS equal RHS. Done. Number 2, NP2 LHS factorial n factorial n minus 2. So n minus 1, then n minus 2 gets cancelled. RHS twice np n minus 2 factorial n n minus 2 factorial n. My fault. I wrote the question. npn. So factorial n minus n, factorial and factorial 0. Factorial 0 is 1. Here factorial 2. Factorial 2 is 2 into 1, 2. Gets cancelled. Factorial n, that is LHS. Done?
Yes, ma'am.
Third. Pn comma n. npn. This is our LHS. Factorial n minus n. 0 factorial, which is 1. So factorial n. RHS Pn comma n minus 1. npn minus 1. Factorial n. Factorial n factorial 1. So again factorial n, which is LHS. P1. We need to find n. n plus 1 P3 equal np4. Factorial n plus 1. n plus 1 minus 3. Factorial n minus 4. n plus 1 factorial can be opened as n plus 1 into n factorial. This is n minus 2 factorial. Factorial n minus 4. Factorial n gets cancelled. N plus 1 equal factorial n minus 2 upon n minus 4. So n minus 2 is larger. So we are going to open that factorial. N minus 2, n minus 3, n minus 4 gets cancelled. Opening the bracket. N square minus 5n plus 6. N square minus 6n plus 5. Midterm. N minus 2, n minus 3. So n has two values, 2 or n equal to 3. Something is wrong. Something is wrong here. My God, midterm is wrong. 5 and 1. N equal to 1 or n equal to 5. But n equal to 1 is not possible. Why? Because I've already written NP4. So if I'm asking you to select 4 things, there has to be a minimum of 4 things. It can be more than that, but it cannot be lesser than that. So n equal to 1 is not possible. Final answer, n equal to 5. Yes. Number 2. 5 times p4 comma n equals 6 times p5 comma n minus 1. 5 times 4pn 6 times 5pn minus 1. Factorial 4, 4 minus n, 6. Factorial 5, 5 minus n minus 1. 5 into factorial 4, 4 minus n. 6. Factorial 5 can be written as 5 into factorial 4. This is 6 minus n. So gets cancelled. So 6 minus n divided by 4 minus n factorial is 6. So 6 minus n is larger. 6 minus n, 5 minus n, 4 minus n gets cancelled. And since left hand side is a product of two numbers, so 6 can also be written as 3 into 2. If I compare 6 minus n equal 3, so n will also be 3. Done? Next, third one. P n minus 1 comma 3 divided by P n plus 1 comma 3 equal 5 is to 12. N minus 1 P3 divided by n plus 1 P3. 5 by 12. Factorial now. Factorial n minus 1. N minus 1 minus 3. Factorial n plus 1. N plus 1 minus 3. That is 5 upon 12. If I change from division to multiplication, it gets reversed. So who looks alike? N minus 1 and n plus 1 looks alike. So the larger number is n plus 1. I'm going to open that. So that would be n plus 1 and n. n minus 1 gets cancelled. Between n minus 2 and n minus 4, n minus 2 is larger. So n minus 2, n minus 3, n minus 4 gets cancelled. 5 by 12. Yes. Cross multiplications. 12 n square minus 5n plus 6. 5n into n plus 1. So 12n square minus 60n plus 72. 5n square plus 5n. 7n square minus 65n plus 72 equals 0. 56 and 9. So you're taking 7 in common, taking minus 9 common. N minus 8 into 7n minus 9. Either n equal 8 or n equal 9 by 7. But 9 by 7 is not possible. We only have natural numbers, right? So n will only be 8. Is it understood to everyone? Guys, any doubt? None. Does it match? Question number 4. 6 candidates are called for interview to fill some vacant post in an office. Assuming that each candidate is fit for each post, determine the number of ways in which 2 posts can be filled. So from 6, I want to select 2, and these are posts like awards, president, vice president, and like. So position matter. So arrangement is also there. So basically 6p2 or 6 into 5. In second one, repetition is, 3 posts can be filled. So 6p3, 6 into 5 into 4, 5. 3-digit numbers can be formed from using the digits 1 to 9. So there are 9 digits. Number 1, no digit is repeated. So out of 9, we need to select 3. So 9 into 8 into 7, 147, 154, 504. Second, digits can be repeated. If the digits are allowed to be repeated, no permutation, no combination. It's normal common sense. So the first place can be filled in 9 ways. The second place can be filled in 9 ways. The third place can be filled in 9 ways. So 729. 6, 1. In how many ways can 6 women draw water from 6 tap if no tap remain unused? That means I basically need to arrange them which woman will go with which tap. There's no selection involved. So in how many ways can it be done? Factorial 6, 720. 7 candidates are contesting an election. In how many ways can their names be listed on the ballot paper? So again, basically only arrangement is involved. There's no selection, there's no cut. So 7 factorial 5040, 7 1. From a committee of 8 persons, in how many ways can you choose a chairman, a vice chairman, assuming that one cannot hold more than 2 positions, more 1 position? So out of 8, we need to select 2 and also arrange them. So we can write 8b2, or directly the first position can be filled in 8 ways. The second position can be filled in 7 ways. Total 8 into 7, 56 ways. Yes. Number 2. From 12 persons, in how many ways can we choose a president, vice president, and secretary and a treasurer? So 4 people, and everyone can hold only one place. So from 12, we need to select 4 people, 12, 11, 10, 9. 11,080. Yeah. Okay. A man has 6 friends. In how many ways can he invite one or more of his friends at a dinner? So if there are 6 friends, it's not about sending an invite, because if you're inviting, it doesn't matter who you send the invite first, right? It doesn't matter. The arrangement doesn't matter. So it's not a permutation question. It's a common sense question. So every person has 2 possibilities. Either the person is going to be invited or the person won't be invited. So the first friend has 2 options, invited or not invited. The second person has again 2 possibility, invited or not invited. The third person again has 2 possibility. So 2 will appear 6 times, one for each of the friend. And we need to consider for all of them. So there's a total possibility of 2 power 6. But as the question said, I'm allowed to invite one or more. That means the possibility of inviting 0 people is not allowed. So how many ways can I uninvite everyone? First person 0, second 1 way, second person 1 way, third person 1 way. So one. So that one possibility where I haven't invited anyone is not allowed. So a total of 63 possibility. Clear? Second, there are 8 true-false statements in a question paper. In how many ways, how many sequences of answers are possible? So first question, there are 2 options, either true or false. Second question, again 2 options. Third question, again true, false option. So 2 will appear 8 times, 256. Clear? 9. In how many ways can 3 different rings can be worn in 4 fingers with at most 1 in each finger? So no modern error. So first ring, how many fingers are available to be using it? 4. Second ring, no. One finger will leave 1 ring. So second ring will have only 3 fingers, the remaining 3. The third ring will have 2. So basically 4 into 3 into 2, 24. 10. Okay, again find the value questions. 5PR is twice 6PR minus 1. Factorial 5, 5 minus R. Factorial 6, 6 minus R minus 1. So factorial 5, 5 minus R. 6 factorial can be written as 6 into 5 factorial. And this is 7 minus R. 5 factorial gets cancelled. 7 minus R by 5 minus R equal 12. So I can open the larger number 7 minus R. So 7 minus R minus 1, 6 minus R, 5 minus R gets cancelled. So here it's a multiplication of 2 consecutive numbers. 12 can also be written as 4 into 3. Comparing 7 minus R equal to 4, R will be 3. R will be 3. Clear?
Yes, ma'am.
Second, P11 comma R equal P12 comma R minus 1. So 11PR equal 12PR minus 1. Factorial 11 minus R. Factorial 12 minus R minus 1. Factorial 11 minus R. This can be written as 12 into factorial 11, and this is 13 minus R. 11 factorial gets cancelled. 13 minus R upon 11 minus R equal 12. Opening the larger factorial, that is 13 minus r. 13 minus r, 12 minus r. 11 minus r gets cancelled. 12 is 4 into 3. Comparing 13 minus r equal 4, r equal 9. Yes. Clear? Online clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Third, P 15 comma r minus 1 divided by P 16 comma r minus 1. 3 is to 4. 15 P r minus 1 divided by 16 P r minus 1. 3 by 4. This is 15 factorial. 15 minus r plus 1 divided by 16 factorial. 16 minus r plus 1. So 15 factorial. 16 minus r factorial. 17 minus r. 16 factorial. So 15 factorial. 17 minus r is a larger number. 17 minus r, 16 minus r. 16 factorial is the larger number. So 16 into 5, 14. 15 factorial gets cancelled. 15, 15 gets cancelled. 17 minus r equal 3 by 4 into 16. That is 12. 17 minus r equal 12. R will be 5. Clear?
Yes, ma'am.
11. In how many words can be formed using all letters, using each letter exactly once of the following word? Basically, just form a word. So number 1, Delhi. Delhi means 5 letters, so 5 factorial. Second, Jaipur. 6 factorial. Third, hexagon. 7 factorial. Fourth, equation. 8 factorial. Yeah. So 120, 720, 5040, 40,320. Understood? Guys, understood?
Yes, ma'am.
Right. That's it for today.